Quadratic functions show up in a lot of different models that you encounter in physics, maybe even some business class models, but a lot of physics and engineering models use quadratic functions to model certain phenomena. So whenever you're prompted to find the absolute maximum or absolute minimum of something that's modeled quadratically like this, it's always going to have to occur at the vertex, because that's unique to a parabola shape. It'll either be a parabola opening up, whose vertex is a minimum, or it'll be a parabola opening down, whose vertex is a maximum. So the absolute max or min for a quadratic function will always occur at the vertex. So here's just a generic function with some relatively weird looking coefficients. Negative 0.32x squared plus 122.6x minus 13.6. For this function, without graphing it, determine its absolute maximum or minimum point or coordinate. In other words, determine its vertex. So since it is quadratic, you see the x squared there, we're prompted for the max or the min. We just need to locate the vertex to find that point. Now, is it going to be a maximum or is it going to be a minimum? Based on the way the parabola is opening, that negative value of a for your x squared coefficient, this would be a parabola that opens down. So I know for certain its vertex is going to be an absolute maximum. It's impossible to have both. If it opens down like this, there is no absolute minimum value, only an absolute maximum. So for this particular function, we can only find an absolute max. So let's go through the two-part calculation for finding the vertex. X equals opposite b over 2 times a, which will be negative 122.6 over 2 times a is negative 0.64. And then if I crunch that out, that's going to be 122.6 over 0.64. The negatives cancel, so I just didn't type the negatives in. So that's going to give me an x coordinate of 191.5625. Okay, now I want to take that and plug it into the function. So that's going to give me y equals negative 0.32 times that 191.5625 squared. There it is plated for the first x on the x squared, plus 122.6 times 191.5625, and then minus 13.6. So when I hit enter there, the y coordinate we're getting is in the 11,000 range. This is going to be 11,729.18125. Now the problem doesn't prompt us for any kind of rounding. It doesn't say to round to the nearest tenth or the nearest hundredth. So I'm just going to go ahead and leave it as it is. This quadratic function reaches a maximum at the coordinate 191.5625 for x, comma, 11,729.18125 for the y coordinate. So whenever you're prompted for the absolute max or absolute min of a quadratic, it's essentially boiling down to finding the vertex. Okay? So given that, I've got another example I want us to work through involving a football snapped from the quarterback. Quarterback snaps to the receiver, and this function h of x equals negative 0.04x squared plus 2.1x plus 6.1 models the pass, where your x input represents the number of horizontal yards away from the quarterback. So in other words, x represents horizontal distance away from where it was thrown, and the y output represents the height of the ball in feet. So be careful. Notice x is measuring horizontal yards, y is measuring vertical feet up above the ground level. So, I mean, that tends to make sense when you throw something like a football. When the quarterback snaps it, it's going to make a parabolic path, sometimes higher than that or steeper than that, depending on how far downfield he needs to go to where he intends to get it received. So let's just find the vertex with this quadratic function. and then reread it when we're asked to interpret what the vertex stands for. Okay, so two-part calculation for finding the vertex. X equals opposite b over 2 times a. So that's going to be negative 2.1, opposite of b. 2 times a is negative 0.08. So let me check that calculation out. 2.1 divided by 0.08. That gives me an x value of 26.25. The y-coordinate for the vertex is going to be the h function evaluated at 26.25. So taking your x-coordinate and plugging it back into the function, that's going to be negative 0.04 times 26.25 squared, and then plus 2.1 times 26.25, and then plus 6.1. Let me double check my calculation, make sure it's consistent. Negative 0.4 x squared, 26.25 for x, 2.1 times 26.25 for x, and then plus 6.1. So that gives me a y-coordinate of 33.6625. So it means our vertex is at that point, 26.25 for x, comma, 33.6625 for the y-coordinate. Okay? And then you're asked to interpret your vertex. So let's reread the question very carefully. The x inputs into this function represent the number of horizontal yards from the quarterback that the ball has traveled. So x is measuring this distance in yards. Okay? The y output represents the height of the ball in feet. So when you go to a certain x and plug it in, it gives you a y-coordinate that represents the vertical height of the ball at that point, and again, that's scaled in feet. So this vertex occurs 26.25 yards downfield from the quarterback, and the ball reaches a height of 33.6625 feet above the ground there. So as part of a correct interpretation, what is the maximum height the ball reaches? That is the y-coordinate from the vertex. So the maximum height is going to equal 33.6625 feet above the ground. Height is the vertical distance, and y measures height in feet. How far downfield does this occur? Downfield is a horizontal measure, so downfield is going to correspond to the x-coordinate for the vertex. So that happens at about 26.25 yards downfield, meaning from the quarterback where he's standing, where he threw the ball. Okay. Now, should the receiver miss the ball, how far downfield does the ball land? Well, here's a rough idea of the path. If he's throwing it from here, the receiver misses it. At some point, that parabola path for the ball is eventually going to hit the ground. Well, if this path represents the graph of the parabola, and the x-axis is not just measuring yards, but is also just the regular x-axis from a graph that you would make, then it looks like it would hit the ground at an x-intercept. So, receiver misses the pass. How far downfield does the ball land? Let's find the x-intercept. Now, keep in mind, there are two x-intercepts, which means one will make sense for the context of the problem, but one won't make sense. So let's go through the process of finding those x-intercepts. And in this case, I probably would go back to the quadratic formula. So if I set up the quadratic formula using the values of a, b, and c we're given here, remember you're setting this equal to 0, so now you're committing to solving it as a quadratic equation. So the opposite of b, negative 2.1, plus and minus square root of b squared minus 4 times a times c. So let me extend my fraction bar. extend my square root. All this divided by 2 times a. Okay, so let me crunch out the discriminant first. The value underneath the radical, 2.1 squared. Well, to make sure you're doing it correctly, you know, the b squared is always going to be positive. So, I mean, technically, you're supposed to do this before you square it. And then minus 4 times negative 0.04 times 6.1. And notice you can use parentheses to represent multiplication as well. So the discriminant is going to be 5.386. So there are two values that we need to calculate. Negative 2.1 plus and minus the square root of 5.386, all this divided by negative 0.08. Well, we're likely only going to need to get a positive answer here. To guarantee a positive answer, you need to look at the calculation involved in your quadratic result. So I'm dividing by a negative number. If I want to get x to equal a positive value for this distance downfield where the ball lands, then that means I need to do negative divided by negative equals positive. So in this case, you're actually going to want to consider keeping the minus and disregarding the plus. Because, again, negative divided by negative equals positive. And if you do that, that'll tell you the positive value for that x-intercept. So my numerator, negative 2.1 minus the square root of 5.386, and then divide all that by negative 0.08. That gives me about 55 I'm just going to go ahead and round that. That's approximately 55.3 yards downfield is where the ball would land if the quarterback or if the receiver misses it. Okay. Now, if you did the calculation the other way, if you did the plus instead of the minus, you'll get an x-intercept that's negative. That actually doesn't make any physical sense in the context of this problem. So, since you're looking for a positive distance away from where the quarterback snapped the ball, then if the receiver misses it, it'd land here about 55.3 yards away downfield.